Hey everyone, and welcome to this edition of Project of the Week. Each week I'm going to recreate a project in Grasshopper that is chosen by my subscribers and followers. This week we're going to be taking a look at the Mathematics Gallery by Zaha Hadid Architects. This project consists of 3 minimal surface objects hanging from the ceiling in the gallery. In this tutorial, we will model the base mesh topology in Rhino and then relax the mesh in Kangaroo to create the curved geometries in the final project. We're not going to be recreating the minimal surface algorithm. However, next week I'll demonstrate how to easily create gyroid surface meshes in Grasshopper. To complete this tutorial, you'll need the Weaverbird plugin for Grasshopper installed. This plugin can be downloaded from the link on my screen. You'll also need Uto's Mesh Edit plugin, which can be downloaded from foodforrhino.com. So let's begin this tutorial with a blank Rhino document. I'm going to begin by just modeling up a mesh plane. I'm going to make the x count equal to 1, the y count also equal to 1. And this is quite important for when we do our meshing in Grasshopper. Then I'm just going to draw a square, and I'm going to make my object pretty scaleless. I'm just going to go 20 units by 20 units for now. Zoom into that guy. I'm just going to quickly model up the base topology of this surface inside of Rhino. So I'm going to go ahead and make a copy of that guy and across here. And then I'm just going to scale it in one direction. I'm going to make it half the length of that initial one. And then I'm going to copy the guy over there and copy both of these over here to create a bit of a mirrored geometry. Copy one more, like that. And we're going to get something like this. And this is where our kind of void through the form that we're trying to create is actually going to happen. So I could go ahead and grab that guy, just copy it, rotate it upwards. Might actually make that one 3/4 of the height. So in my units 15, like that. And do another copy of this. And I'll go ahead and just rotate those guys as well. Move them into place over here like that. So now we're starting to create that void through the middle. Then I might copy these guys up to create that second level there. And I'm actually going to copy the void. So all 4 of those mesh faces up to here like that. And this one can come out here. So we're starting to create a bit of symmetry through this thing. Actually, no, let's not put it up there. That one wants to go up here. So it's almost like symmetry in the opposite direction. We want to get those guys to come up to the top like that. And then I'm going to get this initial mesh plane that we created, put that one there. And then I want to get a side one just there like that. So we get that hole coming through. And then similarly down the bottom here, we want that hole there. And then we just want some mesh faces to cap at the end there. So I might actually copy that guy across there. Give it a scale 1D, like that. And copy that guy over there and do the same over here. So we're starting to get that kind of continuous geometry. And the last thing we want to do is we want to get these little triangular kind of moments in the mesh. So what we're creating here, I'm going to do this by creating a polyline. I'm just going to create a polyline like this, and then I'm just going to go mesh polyline to patch that in like that. So basically what we're doing here is we're creating what's called a base topology. Going to mirror that guy and move him across there. And this base topology is going to be smoothed inside of Grasshopper to create that kind of continuous curved geometry that we see in the precedent that we're interested in. Move these guys up here like that, and then we've pretty much got the mesh that we're after. So I'm going to join all of those guys together and go ahead and reference that straight into Grasshopper. So I'll just give myself a bit more room. Now I'll just make a mesh. Oh, we haven't joined that last little corner there. Make sure your whole mesh is joined. It's not liking that one. I wonder why that is. Just flip it and see if that can fix the issue. It's not loving it. Meshes in Rhino are a bit weird sometimes. Let's just try recreating that one again. See if we can get it joined. Yeah, there we go, one open mesh. I'm not sure why that bug was happening, a bit strange. So let's reference that in, set one mesh, like that. And we're just gonna make sure it's joined by just doing a mesh join. Kind of know it is, but we just want to be sure. We could actually probably just explode it if we wanted to, not even join it, just reference all those meshes in like that. And then we just want to go ahead and we're going to weld the vertices. So I'm going to go mesh weld. Let's use the weld mesh one here, that guy. Just weld all those guys together. And what that'll do is it'll basically merge all those vertex joints that are overlapping. So you see we drop down from 132 to 45. I'm then going to unify the mesh normals. So I'm going to unify the mesh like that. That'll put all of my mesh normals in a self-similar direction, which is quite important for this, like, you know, continuous or minimal surfaces, we're going to call it. And then we want to jump into some Weaverbird. So up here on the WB tab, if you got it installed correctly, we want to select the Weaverbird's Catmull-Clark subdivision. So this is a pretty classic subdivision technique. What it's going to do is it's going to go ahead and take all of these faces of this geometry and subdivide them into smaller faces, but it'll actually create some curvature in our outcome. So I'm going to go ahead and plug the result from that unified mesh into here and preview these guys off. And then I'm going to hide this geometry inside of Rhino. We've got a little bit of a tear going on there. So I think that tear is actually coming from this weld mesh component. It's not the best one. So let's go and use Uto's weld mesh one, which is this mesh weld vertices. I'm just going to swap that guy out there and then delete that weld mesh in there. And then we'll have that tear gone, which is good. So this subdivision level, like, we can kind of visualize what it's doing by checking the face boundaries. So if we go and plug these outputs into the mesh, you'll see it creates like smaller mesh faces of that geometry that we've got. I mean, initially what we had was this. So we're going ahead and subdividing it. So we could go and increase the levels of this. So I'm going to make a slider that's between 0 and 5. And basically if we start at 0, we have our initial mesh. If we go to 1, we go to the next level. We go to 2, you get to a second level, and it starts to get like a lot smoother. And then you start to see this, minimal surface type geometry that we've got that's stemming out from this base topology that relates to our precedent. So I'm going to leave it at 2 for now, and I'm just going to delete that face manager. Let's just leave it actually for now, and then I'm going to create a smooth mesh component. So this guy here, and I'm going to plug in this output mesh into here, and we're going to smooth this guy. We're going to give it 20 iterations of smoothing. Like that. I'm going to leave the strength, I want it to be 1 actually, let's go 1.00. So basically it's going to smooth it by a strength of 1 and then run that 20 iterations. And then I am going to just invert skip naked like that. Preview these guys off. So you get like a much kind of more closed off minimal surface coming out of there. So you'll see like, the difference here if I didn't invert that. It holds all of these naked vertices at their, points in space, but this time we just want to make sure that we're smoothing all that out. And then basically what we want to do is we want to run a Kangaroo simulation. So I'm going to go ahead and just create a bouncy solver like that. And I'm going to go ahead and create a Boolean toggle. What we might do in this one is actually we'll keep it false for on, and then I'm going to invert the input to reset so that basically this toggle controls both. So basically when we flick it on, it'll reset the solver and run the bouncy rather than us having to have a button at the same time, which is a nifty little trick. So the first thing I'm going to do is I'm going to make sure that this solver just shows our mesh. So I'm going to get the show component in Kangaroo and make that one of the goal objects. And then I'm just going to flatten all of these goal objects because we're having a couple of them. We're going to get the naked vertices as well. This guy, so this is a Kangaroo component. Maybe I'll get the Kangaroo to panel up. So that's, where is it? Naked vertices right there. We're going to grab that out of this mesh, and we're basically going to create some anchor points from those naked points. So unlike the smoothing mesh, where we're happy to just smooth those edge points back, during the simulation, we're going to hold them in place. Plug that into there with a shift. Then I'm going to just add a smooth behavior as well. plug that guy into the goal objects. And then the main behavior that's actually going to affect the simulation quite significantly is we're going to, perhaps if we preview this guy back on, we're going to, or maybe this guy, we're going to basically ask Kangaroo to make these edge lengths smaller than they currently are, which will in theory kind of compress this mesh whilst holding its outside form. So it'll give us a really kind of interesting continuous curvature in the form itself. So I'm going to go ahead and get an edge lengths behavior here, like that. And I'm going to plug the smooth mesh into there. And I'm going to make this length factor 0.15. Maybe add a 0 onto that just in case you want to have a bit more control over it. And I'm going to add that guy into the goal objects. So I'll preview all these guys off now. Looks good. And then coming out of here, we're going to get that mesh. So to get that mesh, I'm going to create a list item component. Oops. And that's going to be coming out of O because the top item in that output is the mesh that we want, which is that guy there. So I could, go and create some face boundaries again and watch this run real time. Actually, mesh edges would probably be quicker, I think. Get the mesh edges. So then we can go ahead and run this simulation and you'll see it kind of like snaps into place nicely like that. And then that'll reset it, run it again. And now we pretty much have the form of this, these objects that hang in the mathematics gallery, which is pretty great. So what we want to do lastly in this tutorial is we just want to create the patternation on top of this mesh. So I'm just going to, in fact, I might actually, now that I think about it, I know it's converged. Make sure that your bouncy solver has converged because we're going to add a few things on the end that you wouldn't really want to run whilst the bouncy solver is running. The main one being the mesh pipe. We're basically going to create a big pipe that goes around the outside of this form. So I'm just going to go ahead and I'm going to use another Weaverbird component. So I'm going to use the Weaverbird naked boundary component. And from this this mesh, we're essentially going to, like the naked vertices before them, get the naked curve that runs out at the edge of the mesh. So all of the vertices that are naked, we're just going to join all those up into a curve that looks like that. Gets us the nice curve of the form. And then I'm going to go ahead and create a pipe. From that, I'm just going to plug that curve into there. And that kind of looks like the precedent. So then I might just create a preview, custom preview. And I'll make that geometry, give it a swatch, being like a dark gray, just like in the precedent. Cool. And it might be a little bit too thick. Maybe we could make it a 0.80 as the radius, something like that. Seems okay. Great. And then what we want to do is we want to basically use the Kangaroo stripper component, which sits under mesh from memory. So we want to get the strippers, and what this will do is it'll basically create like strips out of these mesh faces. And because our topology is nicely modeled, this is why we didn't use the isosurface in the end. It's going to enable us to create that stripy pattern that we see in the precedent. So I'm going to grab those meshes and basically it's going to disintegrate these into strips. You could visualize these colorfully if you wanted to. So I could create like a gradient of different colors in Grasshopper. And I could then just create a range of numbers that relate to how many strips you have in that mesh. This is just a diagram. It's not what we're necessarily trying to do here. But what this will basically do is show you how it's stripping that object. So I could go ahead and say, let's, add a mesh colors. And I'm going to graft coming into both of those guys. Basically out of this, we'll get a bunch of mesh colors, 65 of them, and we've got 65 or 64 strips. So, I also want to just jitter them so we can clearly see, just add a bit of randomness into that list. So you see how it kind of creates these strips of colors, basically. We don't want to create these colors, like I was saying. I mean, you could if you want, but what we're going to do is just basically grab the mesh edges of each of these strips, or the naked boundaries actually of these strips, and then that'll create the stripes that we're looking for in the precedent. So I'm going to go ahead and delete those guys, and I'm going to do another naked boundary component here, like that. So then we have all the strips, which looks great. And then I might just add a custom preview to the actual mesh itself. I'll delete this guy here, and I'll make that white like that. And then we basically have the precedent itself. So one thing that you might want to go and experiment with is you could start like changing the density of this. So I'm just going to disable this pipe guy because that's going to slow our definition down. In fact, I'll disable everything back here just for just to make it a little bit easier for us to manipulate things. And we could go ahead and maybe increase the subdivision. I'll make it a 3 instead of a 2. That'll run straight away. And then once we're happy, once it's converged, we'll be able to go ahead and enable all of these guys. And you'll notice straight away that we have a much higher density mesh. I'll just get the mesh edges up again. Give us a clear understanding of that. So that subdivision's given us a lot more faces to deal with. So now when we go ahead and run our stripper, we'll have like a higher density mesh. So it's converged. I'm going to go ahead and enable these guys. And you can see why I didn't want this to run over and over again, because it would run really slow. And then suddenly you have a much higher density mesh going on, just like that. Cool, so we could go ahead and like view this in rendered mode. Like so. And you get these really kind of interesting continuous surfaces coming through. And that looks very similar to the form in the precedent. So as I mentioned, next week I think we're actually going to take a little bit more of a theoretical look at the gyroid form itself. And we'll get an understanding of how these minimal surfaces could easily be created inside of Grasshopper.